Hello everyone, welcome to today's video on how businesses secure cloud environments in the real world. This is a thorough, practical walkthrough for IT professionals, cybersecurity analysts, and cloud engineers who want to move beyond basics into how actual organizations design, implement, and maintain secure cloud setups. So we will start with a solid foundation of cloud computing, then build layer by layer through the key security pillars. Before discussing security, we must fully understand what cloud computing really is, because every security decision flows from this foundation. Cloud computing is not just someone else's computer. It is a model for delivering on-demand computing resources over the internet, servers, storage, databases, networking, software, AI tools, and more, with massive scalability, high availability, and pay-as-you-go economics. Instead of spending millions upfront to buy servers, rack them in a data center, hire 24/7 power cooling staff, and over-provision for peak loads, businesses rent exactly what they need from providers like AWS, Azure, or Google Cloud and scale instantly. The 5 essential characteristics defined by NIST made this possible. On-demand self-service, which is a developer can spin up a server in minutes via a web console without waiting for IT procurement. Broad network access. Resources are accessible from laptops, mobiles, anywhere with internet, enabling remote work and global teams. Resource pooling. Providers use multi-tenancy to serve thousands of customers from the same physical hardware efficiently with strong isolation. Rapid elasticity. During Black Friday or a viral product launch, capacity auto-scales in seconds. No over-provisioning needed. Measured service. Billing is granular, per second, per gig, etc. like electricity. So we use 10 hours, pay for 10 hours. So, the 3 service models determine how much control and security responsibility you have. Software as a service, platform as a service, and infrastructure as a service. Infrastructure as a service can include Azure VMs. It's like renting bare metal. You can only control the operating system, the middleware, runtime, apps, and data. While the platform as a service, it's like application services. It's like renting a managed platform. The provider handles operating system, runtime, patching. You manage app code, data, assets, faster development, etc. Then for the software as a service, we have example of Office 365 as well as the Salesforce. It's like renting a finished application. So the provider manages almost everything. You configure users, share policies, data classification, and lots more. This leads us to the shared responsibility model, which is the single most critical concept in cloud security. Here, the provider secures the cloud infrastructure. So you can secure the cloud, your data, applications, operating system configurations, your hypervisor, as well as your global network. But in the real world consequence, many breaches happened because teams misapplied this model and left configurations exposed. How organizations actually design secure cloud organizations. So we have people, which is the first one here. Under people, you undergo training. Example, security awareness, least privilege mindset, certification programs, and fostering a security is everyone's job culture. We move to processes, which include the formal policies, regular audits and compliances, checks, incident response playbooks, and automated governance. We move to technology, which we have the IAM for access, network segmentation, continuous monitoring, and encryption everywhere. The overarching business goal is to protect sensitive customer data, like the PII and the financials. Avoid multi-million-dollar breaches or fines. Maintain trust and achieve compliance with the GDPR, NDPR in Nigeria, HIPAA, and the PCI DSS. So in practice, companies like banks or retailers start with risk assessment, then they layer that their defenses. This is what happens in the real world by design mindset. The IAM, which is the gatekeeper of cloud access. IAM stands for Identity and Access Management. So IAM answers, who is this user's device? What are they allowed to do? Businesses implement role-based access control because individual permissions become unmanageable at scale, hundreds of users, thousands of resources. So role-based access control assigns permissions to roles, then attaches roles to users or groups or services, which makes it easier to audit and revoke. So under role, as you can see, we have the admin who have full permissions. The admin has full permissions, which can be limited to 2 to 5 senior architects. So, for instance, if there's a risk, the admin has full rights to take over or control the environment. We have the developer, whose job is to create or update only, but he or she is denied the permission to delete or terminate. We have the viewer, who has the right to only read. He does not have the right to delete, create, terminate, or whatever. The viewer only has the right to read, which enables compliance reviews without any risk of change. So why does this matter? Overprivileged accounts are the number one attack vector in cloud breaches, which are the insider threats or the stolen credentials. So we have least privilege, which reduces blast radius dramatically. This is foundational. No strong IAM means that the rest of your security will actually crumble. Move to the next slide. Top high-risk cloud security misconfigurations. Now, the painful truth is that top high-risk misconfigurations that appear in nearly every cloud breach report OWASP. So we point to this, for instance, publicly exposed storage. Millions of records are leaked. Why? Because the default is private, but one click makes it public forever. Overly open security groups, which is inbound, or databases. So brute force and ransomware entry points is this: overly open security groups. Overly permissive IAM rules, policies with action and resource. So this actually allows for privilege escalation. Example, where an attacker creates admin accounts. We have no minimal logging, without cloud trail, no audit trail for incidents. Here, your regulators can be fined heavily. These are often human errors during setup and migration, but the impact is catastrophic. The impact can be data theft, extortion, fines, or reputation damage. Network security. Network security actually controls traffic flow to stop attackers moving laterally. So we have the VPC, which is your private, logically isolated section of the cloud, where we have the subnets, both public and private, route tables, and internet gateways. Security groups are like the instance level stateful walls, which only allows only specific ports or IP addresses, and it returns traffic auto allowed. We have the network SCLS, which includes subnet level stateless firewalls. It is like an extra layer for deny rules. Core principles: deny by default, explicit allows only, from anywhere. So public subnets for load balancers, private for databases, can make attackers reach sensitive resources even if they breach the web tier. This defense in depth stops 90% of lateral movement attacks. Monitoring, seeing threats in real time. Monitoring can turn data into actionable visibility. Here you can have things like the cloud logs, where every API call recorded can be seen. The cloud trail logs who, what, and when or where an action occurred. Alerts is when rules trigger notifications. Example, login from unusual country, crypto mining, etc. The dashboard is where real-time views of metrics, logged threats, investigations are noticed or correlated. Then we have the business value, which detects anomalies in minutes, not months, critical for compliance and reducing dwell time. Without these, breaches go undetected for months. In summary, strong IAM plus least privilege is your core defense. Ensure you fix misconfigurations early because they cause most of the breaches. Network segmentation plus monitoring gives visibility and fast response. These practices directly support compliance, drastically reduce business risks, and are highly sought after skills for cloud engineering, cybersecurity, and security careers. Thank you for watching. Ensure you keep yourself, your businesses, and your devices safe at all times. Thank you. Bye.